Friends, we're going to start with one of my favorite things to do every year. I'm going to attempt to prove to you the area of a circle using the area of a parallelogram equation and an orange.
What?
I know.
Are you gonna eat oranges?
That's the right reaction, kids. So stay with me. You don't have to write this part down. Just really use your brains hard.
Yeah.
So here is a picture of an orange slice. You guys know what orange slices are?
Yeah.
Like that round thing, okay? And when you go to eat this orange slice, you like break it right here maybe.
No one breaks their
And you could roll it out flat. So imagine this, right? I know I'm a beautiful drawer, but
see that.
you can see you break the peel, and you open it up flat, right? Now, in the middle of this slice here, and I'm doing this better than first, like this right here, what would that be in the circle? What would you name that part of the circle? Camille? The radius. Okay, so I'm just gonna just to keep it solid, that's the radius. And this, the peel, what would that be in the circle? James? So across? Circumference, right? And for our cases this time, I usually use C as pi d. But for this, we're going to go 2 pi r, actually. It's the same thing. It's gonna do what I'm trying to do better, though. The 2 pi r, though.
I can't see.
Okay, so now we're going to then cut this in half there and flip over the sides. And so if you do that, again, I'm a great drawer, I know. If you do that, they kind of like interlock, right? Can you see that? The little triangles would interlock each other. And this height here, my height would still be what? The radius, right? But now along the bottom would be how much of the circumference? Half. So if I take 2 pi r and I divide by 2, or cut it in half, I get pi r, right? So that means my base of this rectangle or parallelogram is, oops, I'm getting ahead of myself, pi r. So for this rectangle we made out of the orange slice stuff, we've got pi r times r, which is pi r squared.
That's crazy.
So we just proved using an orange and the parallelogram area equation that the area of a circle is pi r.
Wait, so you would find it? Okay, can we go?
Well,
If I had a microphone, I'd drop it, but it's stuck on my neck. There you go, right there. But we're not done, so it's not
Wait,
really
so
much
how
of it.
is he-
Let's get the parts of our circles down. I'm going to try my best to draw a perfect circle here. We'll see if I can get one. I think I can do better. There we go. So, oops. We're also going to draw some things into our circle here.
Wait, I can't.
All right.
Where
So
you're standing is blocking up the entire board.
here, well, I need my computer to pick up my voice, Tina. So let's go right here.
You
All
just
right.
told everyone on.
So, here is a circle. We're going to start labeling parts. Camille already kind of told us about the radius, which is right. We'll write radius here. And draw an arrow to the radius. And our radius goes center to outer edge. Okay? And the radius goes from the center of the circle to the outer edge. Anything else you know about the radius? Yeah, Lauren.
Radius times 2 centimeter.
Yeah, so that's true. Let's write it as half of the diameter in parentheses. So that's the same thing you said.
Can I
Yep.
write
The
R?
radius is half of the diameter. So if we're talking diameter, that's this longer chunk. Okay. Mike or John, how would you explain what the diameter is?
It's just a line going directly through the center of the circle.
So distance through the center of a circle, edge to edge. Okay. So it's important that it goes to the center, like this right here, not the diameter. Right? This right here, not the diameter. But through the center, side to side, diameter all the way. And in relation to the radius, what do we know? Twice the radius. Right? If we have a radius twice, that'd be the same distance as the diameter. You can kind of see it right here. Like a radius and a radius would be the diameter, right? Alright? So we got radius, diameter. We also need to know circumference. So the way I like to think about the circumference is all the way around, right? So the circumference is distance around. Circumference is the distance around the circle.
Isn't it like...
And we have an equation for it. There's two equations you might see pop up. There's a more popular equation you might see online or something, and then the one I use, which is less popular, but they're actually the same thing. For circumference, I like C equals pi d. That's my personal favorite. Circumference is equal to pi times diameter. The other thing you'll see is C is 2 pi r, which is the same thing. If I double the radius, what do I get? I get the diameter, right? They're the same thing.
How would you do like pi times 2?
2 times pi, or pi times 2. Or you might use 3. We'll often use 3.14 instead.
Would you have to keep it as 2 pi?
So if I asked you for an exact answer, this is a great question. If I asked you for an exact answer and we're dealing with circles, pi has to be in your answer. Because what type of number is pi?
Is it infinite?
Irrational. Right? 3.14159, no pattern, goes on forever. So the only way to write an exact answer dealing with something circle is to have pi in it. A lot of times we're going to use like 22/7 or 3.14 as getting close.
So would we basically just write it as like...
We're going to use 3.14
so
today.
like 2 times pi would just be 2 pi.
Or 2 pi, it is, or 2 times 3.14 to get close. We're going to use 3.14 today in your homework and stuff.
But if it's like an infinite...
So 2 times pi.
Yeah,
Is
so
there a way
there's-
to solve? Is there a way to solve pi? Like, is there a way to
Yeah.
figure out the pattern?
Interesting. So Tanya asked about to solve pi. One thing I'm going to point out is, this is like a little sidebar. Don't write this, okay? But if C equals pi d, remember we did literal equations? If I want to solve this equation for pi, what would I do to both sides? Divide by d. So pi is the ratio of the circumference to the diameter of any circle. It always works. But that's what pi is.
Wait, so like...
But it's an irrational number. The only way to say all the digits of pi is to say pi.
So let's say...
So, I need to show you one more equation. And this last equation is for a sphere. And this one we just got to memorize. What's really cool is, what's the only piece of information to get the volume of a sphere? What's the only thing we need to know? What's the only piece of information we need to get the volume of a sphere? Yeah, the radius, that's it. That's all we need. Give me the radius.
Wait, but a sphere is like a 3-dimensional object.
Correct.
So how does that have a radius?
Center to outside stuff.
Oh,
Yeah.
well,
So that's kind of just a little one-off. We're only going to do one example today, then you're going to see why. Did everybody get this down? Because if you get a sphere, you're going to want this in your notes. 4/3 pi r cubed. Volume. Okay. So here's your challenge. I'm telling you the area of a circle is 200.96 square inches. And I want you to use 3.14 for pi.
0.9 what?
200.96 square inches is the area of a circle. I want you to tell me the radius, diameter, and circumference of this circle. So work with a partner or people close by. Close by, we can't be moving around. I'm going to open up breakout rooms in the Zoom. So let's reconvene. So from earlier today, we explored area being equal to pi r squared with that orange in the parallelogram, right? So I'm going to take the information I know, and I'm going to throw it into my equation. I know that the area equals pi times the radius squared. So the piece of information I can get from here is the radius.
Yeah.
I'm going to divide both sides by 3.14. And I'm running out of room, but that's cool. So radius squared then equals 64. And you may recall from Unit 1, to undo a square of something, we square root. Which means what times itself equals 64?
8.
8. So I have a radius of 8 inches. I got one piece of the puzzle here. 8 inches. Now, this next piece I think is kind of nice. How do I get from radius to diameter?
Multiply by 2.
Yeah, I double it, so I've got 16 inches. And then how do I get from diameter to circumference?
Multiply by 5.
Times 3.14. What do I get?
50.24.
50?
You left it on the homework.
50.24.
On the homework, it
Inches.
says area equals.
All right. So, again, the best approach for something like this is saying, what do I know? How can I use it? Versus, what steps do I do? Because if you know the area, what's the only equation we have for area? The area equation, right? So that is equal to pi r squared. If you start with that understanding, then you have something to attack. I can find the radius. Well, if you know the radius, you know the diameter. If you know the diameter, you know the circumference. You're going to be it's not going to be as good of thought process if you start with what steps did I do last time I did this problem, right? So think a little wider. Think, what do I know? How could I use it? And you're going to be better able to problem solve through things like this. And like the reason I chose this is we have one example problem that covers everything versus here's one, here's one, here's one, here's one. All right, so that's it for circles, guys. We'll practice spheres a little more on Thursday. So some people call them circles. You ever hear that?
No.
Why is it two C's and one sounds like S and the other sounds like K? Couldn't it be circles or circles? Circles, circles, or circles? It's messed up, guys. The English language is messed up.